Last day, what we did is the fact that we have completed our chapter wavy curve method. The final chapter of inequalities wavy curve method is completed. Now we'll just hop on to another chapter that we know as the coordinate geometry. We all know about coordinates, the polar. No, you might not know about polar coordinates, the Cartesian coordinates, but we know the basics such as ordinate. We know ordinate, abscissa, okay, what is the spelling? Abscissa, yeah, most probably like it. Forgive if it is wrong. Ordinate, abscissa. These type of things are there, we have learned. We know that coordinate geometry will write things as this x comma y, where this here stands for the x coordinate and y stands for the y coordinate. Yes. We also know the fact that we straight lines. A graph. This is y-axis, this is the x-axis. We know that this is called a first quadrant, second quadrant, third quadrant, and fourth quadrant. Here, x and y are positive. Here, x is negative, but y is positive. Here, x and y are both negative, and here x is positive and y is negative. We know this. This is called as first, okay, second, third, fourth. Yes. Quadrant. Sorry, I just forgot the name. Quadrant. Accidentally, somehow I forgot the name. This is called as quadrant. Yes. Now these are the basics. Now moving on, we'll discuss something that is greater than nothing. Coordinate geometry. These are the basics where we have done these in our previous classes. Means not here on this channel, but in class 8 or 9 probably. Okay. So moving on, first we'll learn about the types of coordinates. Types of coordinates. You might be seeing coordinates are two types, x coordinate and y coordinate. I'm not talking about that actually. I'm talking about the fact that coordinates are of two types. One is x and y. No. One is Cartesian and one is polar. We have done trigonometry. Yeah, of course. Cartesian and polar. What is the Cartesian coordinate? The Cartesian coordinate is something like this, x comma y. Where this is our x coordinate and this is our y coordinate. Yeah, this is actually Cartesian coordinate. Now we'll write a form of representation of the Cartesian coordinate which you know as the polar coordinate. Yes, yes. Now polar coordinate is written as r comma theta. What is this? This is the Greek alphabet theta. What is this? This we know as the hypotenuse. How did hypotenuse come into coordinate geometry? We'll just see. Before, let us draw a graph. Straight, straight. And what you know is the fact that This is y and this is x. Now suppose we take a point P here. We take what? We take a point P. It is x1 comma y1. Okay. There comes down a dotted line. From here another dotted line. This whole value is y and this whole value is x. Okay. Yes. And another fact is that yes, this is now what is r and theta? We'll just see here. You know what is r? R is the fact that the displacement from origin to the point is called r. What is this? This is r. And what is the theta? The angle between x axis and the r is theta. Yes. So from here we get this is a right angle triangle. This is x. This is y. This is x. So what we get r as root over of x square plus y square. Yeah, we found the value of r. And this is theta. This can be anything 60, 90, 100, anything. Okay. So let me share something. Yeah. Like we say that 1 by 3. Yes. Suppose this is tan 1 by 3. Yes. This is 1, this is root 3. What is r? R is not x square plus y square. In place of x, there comes root 3. Root 3 whole square plus in place of y comes 1. This comes as root over of 4, which is 2. Yes. Therefore, if we want to write the coordinate, it comes 2 comma. What is the theta? If we write tan theta, here tan theta is 1 by root 3, which implies theta equals to 60 degree. Not 60 degree, it is 30 degree. Okay. So we will write it as 2 comma 30 degree. Simple, quick, easy, yes. Okay. Now you know, in physics, in motion chapter, we did it as the slope. What it was known as? It was known as the slope. Yes. So what is the basic way of writing what? What is the basic way of writing an equation of coordinate? It is the way that the basic form is ax plus by plus c is 0. This is the basic line. Okay. Now what it is? It is the basic line of coordinate geometry. From here we can find the points of x and y. How? X plus by equals minus c. Then it comes the fact that it is x by minus a by c. Now minus c by a plus y by minus b by a equals 1. Okay, it's not visible at all. This is minus b by a and this is y by minus. Oh, what am I writing? Minus b, not b. Oh God. Minus c by a and this is minus c by b. And these are the intercepts. What do we know about intercept? Intercept is where the x coordinate cuts the x-axis. Let me show you. Wait. Oh no, sorry. It's gone. Ulta. Yeah. See here. These are y-axis. This is our x-axis. Now the point on which the point cuts the x-coordinate is the intercept. What is x? This is minus c by n. And what is y? This is minus c by b. Okay. And the point here, it is our just the coordinate. Therefore, the coordinate is minus c by b, comma, minus c by a, comma, minus c by b. Perfect. And what is the slope? Slope we do in another way, like okay, and this is our slope theta. We do it in another way. And the form of equation is y equals mx plus c. Okay, this is also a basic form. This is also a basic form of this linear, not linear equation, these are linear equations of two variables. It is in the way that, how did this black come? I need some, yeah, this color. See here the m is slope and the c is intercept. Okay, if suppose y equals to 3x plus 5, it shows that the intercept will be at here. This will be 5. No, this point will be 5, and this tan theta. Okay, this tan theta equal this 5, and this will be something 5, and this 5 by something. Let me know. Let us name it as x equals 3. Then x equals 3 by 5. Sorry, 5 by 3. I'm doing so many mistakes today. X equals 5 by 3. Yes. So then we can find out what is the value of theta. Tan theta equals 3. It equals, I don't know actually. Yeah. But we found the intercept also. This is 5 by 3. Yes. This is also another way of doing them. But I prefer this, as this works everywhere. It is useful, very useful, and this is also very useful. Okay, we have learned about types of coordinates, the Cartesian, the polar. I've told you that Cartesian coordinates are like this, and this our polar coordinate. Yes. So what to do next? Anything's left? No. If anything's left, I will teach you next. Now see. This is y-axis. The x-axis. A point is here. It has coordinate x1, comma y1. Okay. And the point is here. It has coordinate x2, comma y2. Okay. What we need to find is that the distance. What? The distance between these points. Okay. So from here, how can you find it? Just we need to find out in a way that Just we have to find out in the way that num 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 num. Yes. Let's take white. We join this. Okay. And another joined from here to here. Yes. Now see, what is this? This part is y1, na? Y1. What is this? This is y2. What is this? This is x1. And this whole part is x2. Now see here. What is this part? This whole x2 minus x1. Understand now? This whole part is of x2. And from here we subtracted the x1 part. Then we get this. Perfect. Yes. It becomes x2 minus x1. Now see here. This is y2. Now if this whole part is y2, we just subtract this. Then comes this. This part we subtract. Okay, this part we just subtract from here. So this part remains. This part is what? Y1. So what does this part remains? It remains as y2 minus y1. Yes. And what is the distance? It is right angled. Therefore, the distance is this hypotenuse. What is the hypotenuse? Therefore, the distance from, let the points be A and B. Distance from A to B is a square. Sorry. Yes. Root over of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So here we just derived something known as a formula. We derived our distance formula. This formula applies for everything. If some coordinates are given, then you need to find the distance. Then this formula will always work. Yes. This was a good now. This is x2. Let me explain it again. How did it become x2 minus x1? This part is x2. And we cancel this part from here. This whole is x2 now. From here to here. From here to here. Now, this whole is x2 and we cancel this part. Then remains from here to here. And this x1 part is cancelled. Therefore, it becomes x2 minus x1. And since they are parallel and same, therefore, it also becomes x2 minus x1. Okay. I think you have understood the y2 minus y1 part. Okay. Done. Quick, easy, perfect. Yes. Let's do some maths. Find the distance between two points A whose coordinates are 1, 3 and B whose coordinates are 2, 5. Yes. First you try it, okay? Then see the solution. Now, a thing is must in Cartesian means this part. What it is diagram. The diagram we show is here. This point is A, which is 1, 3. And this point is B, which is 2, 5. And from the distance formula, we know that root over of x2 minus x1 whole square minus y2 minus y1 whole square equals root x2 value what? 2. 2 minus 1 whole square minus not plus it should be. Y2 is 5. 5 minus this is 3 whole square. It becomes root over of 1 plus 5 minus 4. Then it becomes root 5. And root 5 is our answer. Yes, simple, quick, We'll do problems more. But before that, let me show you something. We've learned about Cartesians and polar, how to convert them. This is a very long process. The shortcut process is that, see here. Yeah. Let it be straight now. Yeah, now see. This is y. This is y coordinate, this is x coordinate. Now suppose a point is here. Yes. And this is our x. Sorry, this is r, okay? This is x, sorry, y, and this is, everything is yellow. How can this work? I can escape this map unless you show. Yeah. Hey, yeah, no, I need to make new colors. Yeah, green. Straight line here to here. This part is x, this part is y. Okay. Now see here, r is x root over of x square plus y square. And this is theta. Theta. Now to convert from x comma y, the coordinate is given in the way that is r comma theta. Yes, the polar coordinate. How to convert it into x comma y? Look, this is x. Now what is sine theta? Sine theta is what? Y by x, sorry, y by r. Then y equals r sine theta. Yes. What is cos theta? Cos theta is x by r. Then what is x? X equals r cos theta. We got both the points. Yeah. Therefore, if we want to write it in the Cartesian form, is equivalent, we use the equivalent sign, then we will write it in the way that it is r cos theta, comma, r sine theta. Yes? Yes. So this is our conversion. Today we have dealt up to this. Next day we'll do about this such type of problems on them, and more or less distance and some new formulas, sector formulas, and more on them. Therefore, so thank you. Goodbye. Good day.